Exercise 89 addresses an essential skill, an essential method of practicing our understanding of the derivative. It's what we usually call juggling with graphs in class. So with a graph of f or f prime or f double prime, answer questions about the others. So in this case, we have the graph of f, and the questions that we need to answer will be related to f prime and f double prime. So it's good to be able to answer these questions. It's also good to be able to ask our own questions when we are given a graph. So for simplicity's sake, this time I reprinted the question. So the graph looks like it's a cubic function, and in question A, we have to answer for which values of x is f prime of x 0. So by what we've studied before, we know that f prime of x is 0 when the slope of the tangent is 0. So when the tangent line is going to be horizontal, so it looks like it's here and there. So question A, the answer is x equals -2 and x equals 2. For what values of x is f prime positive? F prime positive means that the slope of the tangent line is positive. It means that the tangent line is going up. So it's going to be the case in all these places here where the tangent goes up. So we can answer like this. It's between -infinity and 2, and also between 2 and infinity. Now, finally, for which values of x is f prime negative, it's going to be where the tangent line goes down, all of these values between -2 and 2. So that answers question A. Question B, for which values of x is f double prime 0? F double prime is 0 typically where there's a point of inflection. For points of inflection, we need not just f double prime equal to 0, but f double prime changing sign. But we first want to look at what we need here is just to find points of inflection, and it looks like it's right here that we have a point of inflection. F double prime is negative, and f double prime is positive. So to answer question B, we can just say that it's at x equals 0. F double prime is positive every time the graph is concave up. So it's for all values from 0 to infinity. And finally, when f double prime is negative, that means the graph of the original function f is concave down, so it's from -infinity to 0. If you answer this by writing x greater than 0 and that x less than 0, it's perfect, no problem. Question C, on what interval is f prime increasing? So, f prime increasing, this is where it becomes a little bit more complex. We have the graph of f, and we are answering a question about f prime. But what does f prime increasing mean? Anytime a function is increasing, it means that its derivative is positive. So what is its derivative? The derivative of f prime is f double prime. So now we have a question that is easier to answer. When is f double prime positive? It is the same as what we had here. So we can say between 0 and infinity. Question D, for which value of x is f prime minimum? So f prime is going to be minimum when its derivative changes from negative to positive. F prime minimum when its derivative, f double prime, changes from negative to positive. So the only possibility is when it's f double prime equals 0, that's a candidate. The only answer to f double prime equals 0 is given right here, x equals 0. Is it really changing from negative to positive? Yes, it is, because f double prime is negative before 0 and it's positive after 0. For this value of x, so for x equals 0, how does the rate of change of f compare with the rates of change of f for other values of x? The rate of change of f is f prime, rate of change of f, that's f prime. So we just found the minimum of f prime. So to answer this question, we can just say it's smaller than any other value, than for any other value of x. Yes, it's the minimum. So think about other questions you may be able to ask using this graph. Maybe what we could ask is, for what values of x are f prime and f double prime both negative? You can think about that and think about other questions you could come up with.